Hello, and welcome back to Autodesk Inventor Training, Part 2. In this part of the training, we are going to be building some more parts and sketches and following up on the Part 1 that we did last week. If you have not yet seen Part 1, I encourage you to take a look at that first and view that training before taking this one. We are going to be building on to all of the experience and things that we learned in part 1 and continuing. So I don't want you to be lost in part 2. So please take a look at part 1 if you haven't done so already. For our part 2, what we're actually going to be doing is we're going to be creating a couple of objects, and the purpose of these objects is we're going to build them. They may look familiar to you, and they're pretty simple objects, but what we're going to be doing is we're going to be building them and then with the intention of actually combining them together. Much like how when you take parts for a robot and you have some parts that you purchase off the shelf and you have models for them that you can include into an Inventor assembly. And then there are some custom parts that you have to build that are made by hand or made by milling machines or lathes or 3D printers. And to be able to combine multiple models together and construct them into an assembly. So multiple parts together to create a bigger solution. And so we're going to be starting out with building some of our own custom parts to kind of eventually assemble them together. So we're going to start out by, again, building 2D sketches and creating extrusions to create three-dimensional models out of them. Things that you're going to learn throughout this process is how to work with circles. We've done a little bit in circles, but more for like creating holes and things like that. Construction lines, we've done a few things with construction lines already. We've done some constraining points, and so there's going to be some additional types of constraints that we're going to use in building these new models. We're going to be using a circular pattern tool. We used a rectangular pattern in our part 1 of this session where we had the drill holes in that gusset. Now we're going to actually be using a circular pattern, so I will teach you how to use that tool. Again, using extrusions, which is review. We've done that in part 1 as well. 2 other tools called trim and extend, which you'll find very handy when you are making your own parts. So that will be a neat thing for you to learn. Projecting geometry and fillet and chamfer. So these are some of just a few of the things that we're going to learn along the way. By the end of this, you will have most of what you need to be able to make your own parts for contribution in your robot. It doesn't mean that you'll be an expert in Inventor CAD, but it will give you the introduction to each various types of tools within Inventor, so that you can at least figure out how the rest of the tools in Inventor work. Giving you this kind of base understanding of how the tools operate will help you be able to follow along if you, say, look up a tutorial on YouTube for how to use certain types of tools. There's lots of videos online on YouTube. Autodesk themselves have a great video library of how to use a lot of these tools, but they can be difficult to follow if you don't have kind of a base understanding as to how the tools work. So my goal here is to get you to understand how the tools work so that you can apply that to other tools that we may not cover in this training. So with that said, let's move on and take a look at what we're going to do. To start out, we're going to create a mounting hub. And so this mounting hub is pictured in the previous slide, has a hub and some mounting points on it, and we're going to make that part. And what I'd like to do is, again, like we did last time in part 1, start a new part and select the tools menu from the top toolbar and set up the document settings and change our units to inch. So I'm just going to start out doing that. So I have Inventor open. If you don't have Inventor open yet, please do so. It does take a little bit for it to start up. So once you have it started up, the first thing we're going to do is we're going to change the units of measurement for this. And so the way that you do that is you go to the Tools menu at the top and then select Document Settings. And then under Document Settings, there is a Units tab, and we switch it to inch. Mine is already an inch. You might have it in millimeter already, but let's all just make sure that we're doing this in inches. For our milling machine at Woodland at 4678 is expecting inch measurements. That's just the way that it's been set up. However, the 3D printer that we have is set up in millimeters. So when we do this, a lot of times I'll set the unit of measurement to match the machine that I'm going to be creating it for. It's not, I don't think, necessary. You can switch the units at any given time and it will be fine. But for me, I don't know what it is. It's just habit for me. Whenever I know that I'm going to be making something on the mill, I do it in inch. And when I'm doing it on a printer, I do it in millimeter. I'm not sure why, but that's the way that I do it. So for this here, we're setting it to inch, and now everything that we draw in here is going to be using inches as the unit of measurement. So the next thing that we want to do is we want to create our base hub. So we want to start out by creating something that looks like this. Okay, we want to have a circle, and that circle, the outside of that hub is going to be 5 inches in diameter. And then there are a series of other circles that go around the perimeter of that disc. And those are going to be located 2 inches from the center of this circle. So the center of the smaller circle to the center of the bigger circle is 2 inches. And then they will be going around the perimeter of the outer circle, and there will be 5 of them. This is eventually where bolts will push through to mount, say, a rim onto the hub. So we want to create openings inside of this back disc for bolts to pass through to fasten a rim to this hub. So let's start out and kind of plan out how we're going to do this. So for me, if I'm looking at how I'm going to create this sketch, I'm going to start out with a 5-inch circle, and I'm going to make it locked in on origin on my sketch, because then that way I know that it's going to be fully constrained and it'll turn from green into this purple color, and so it can't be moved anywhere else on the sketching plane. It's going to be locked into place. So that's where I'm going to start. Then secondly, I'm going to create, I need to create these other 5 holes. Now recall from part 1 when we were making the gusset, when we needed to put a few holes for the rivets on the gusset, there were ways that we could have done that where we manually drew the circles on there for the holes, individually placed each one, and created constraints for distance from the edge and distance from each other. And there was a lot of work to do in doing that. So I showed you how to create a pattern out of this, where you could control the number of holes to create, the spacing between them, things like that. We're going to do something similar, but we're going to use a circular pattern instead. So to do that, we're going to start out with drawing one smaller circle, anchor it into place, and then apply a circular pattern. So let's do those steps now. So we're going to start out creating a new sketch. And again, I'm going to pick the XY plane to start out my sketch. I'm going to grab the circle tool, and I'm going to start out in the very center of my plane and lock it in on origin. Recall that the outside measurement of this circle was to be 5 inches, or a 5-inch diameter. So there we see that it's gotten bigger than my screen, so I roll with the mouse wheel, and I come out, and there is the outside of our circle. Perfect, good start. The next thing is I want to draw another circle that is going to be for those bolts that I need to add. This bolt hole is supposed to be 1/2 inch and 2 inches from the center. So if I enter 1/2 inch here, and it needs to be 2 inches from the center. So if I grab the center here, and then I click the center here, there'll be a line that comes here. Now there's something kind of tricky going on here. If I set this like this, and I set 2 inches here, what you'll notice is now if I try and move this, it's going to make sure that I'm always 2 inches in the X direction, the Y direction from origin. And this really isn't what I want it to do. I want it to be 2 inches from the center in all directions. Okay, so this dimension is saying dimension the center of this circle to the center of this, and it can be anywhere along the x-axis so long as it's always 2 inches along the y-axis. That's not what I want. So I can get rid of this dimension here, and I'm going to place this circle closer by, just to make it a little bit easier to see. And what I can do is, again, bring this dimension tool, click once in the middle there and once here. So you'll notice if I do this, I'm right back into this situation again, right? And that's not what I wanted to actually do. What I want it to do is from the center. So you'll notice that that highlighted dimension, the kind of ghosted measurement sits there, and then it goes away when I get into a certain area near that diagonal point where I want it to be. And you see that the mouse pointer actually has a small icon that changes, that has it on an angle. That's not insignificant. That's actually telling you something that we want to take advantage of. That icon with the angled line and arrow goes away when I'm out here. Okay, so it's telling you something, and this is exactly what we want it to do. So when you have it with that cursor like that, it's saying, hey, do you want me to put a dimension that's on an angle? Because that's what I think you want by the fact that your mouse is right into this area here. You want it as an angle. And so click single in there, and now you see that that's what we actually want. Okay, so now if I click that to set that, and I set this to 2 inches, now it's 2 inches from the center. And now if I go and I grab this, you'll see that it's actually sticking 2 inches from the middle of the circle now. Okay, and that's more of what I want. Okay, so I'm going to do that again, just repeat it for a second so that you can see what's going on. So I select the dimension tool, select the center here, select the center here. And if I move out here, that may be a dimension that I want at other times, but it isn't what I want right now. So instead, I get into this region between the two circles until that cursor shows up with the angled arrow and say, that's what I want. And then I set that up by clicking with the left mouse button. I accept that this is going to be 2 inches, and there it is. So now I actually have this positioned where I want and constrained around the origin circle of the bigger circle. Okay, so I can grab this and move this, and it's always going to be 2 inches from the center. I want to make this so that it's more constrained though. I want to kind of lock this into position. So I can use a construction line to lock that in, or I can use another kind of constraint, like a vertical constraint. So I can say that vertically, and you see the icon is a vertical line, I want the relationship between the center of this circle to be vertically in the same position as origin. And so now I've locked those two together. And I press escape to get out of that tool. And now I can't move this circle anymore. It's locked in because I've said I want it to always be aligned with origin, and I want it to be 2 inches from origin. Okay, so now everything that I have here is locked into place. So far, so good. Now we're to the point where we want to have an additional set of circles in this disk or in this plane. Last week in part 1, we used this rectangular pattern to achieve what we needed to for the gusset. This time we're going to use something called a circular pattern to achieve something similar. Okay, so click on the circular pattern and you'll see that this dialog, if you go back and you view last week's video again, you'll see that the rectangular pattern dialog looked somewhat similar to this. And all these pattern dialogs will look similar. They expect you to select a piece of geometry that you want to create a pattern from. And then they want you to also select how you want this pattern to flow. So in this case, you see when I bring up this dialog, the geometry button is already selected. And now I can pick one of the things that I want to make a pattern of. So in this case, the circle is what I want to make. The smaller circle is what I want to make a pattern of. So I click it and it turns this light blue. The next thing that I want to do is I want to identify where the circle center needs to be. So I'm going to go, where the pattern center needs to be. So in this case, I'm going to select the center here. And you see what appears here is some ghosted sort of circles saying, this is what I think you want, or this is what the current configuration is saying that you want. I want to have 5 of these circles here. It has indicated that I'm going to make 6, which isn't what I want. So I'm going to change this to 5, and now I have 5 circles. You can control this to actually say, I want to have 5 circles spread across 180 degrees. So you can see here that there's 5 circles and they only take up half the disk. This is something that maybe you want to do, or you want it on the other side of the disk going around the other direction. So say if I want to have it 90 degrees, 5 holes through 90 degrees, but I want them over on this side, I can reverse the axis and have it go the other direction. Okay, so there's different ways that you can control how this pattern operates. For my use here, I want to have all 5 holes evenly distributed around all 360 degrees of this circle. So this is looking pretty good. So I'm going to click on OK here. And now I have these things here. I'm not quite sure what, oh, there it goes. All right. So now we have the 5 circles and the larger circle, and they're all in, all fully constrained. If you want to change some of these settings and say, well, actually, I want it to be 6 bolt holes rather than 5, you can go in here and click on one of the circles here. You'll notice that any one of these circles, you get an option here. If you right click and you see the edit pattern button, you can actually go and edit it and then change any one of these parameters for how many you want and the number of degrees that you want it to flow through. However, you can't change which things are going to be participating in the pattern, and you also can't change the home position of where the circular pattern is going to be centered upon, and you can't change the direction or the axis that the pattern is going to have. If you do want to change those items, you'll have to remove the pattern and apply a new pattern. So you can actually choose here to say delete this pattern and change those parameters. So we've got our layout the way that we want, and it looks like the picture, which is great. So now we can say, finish this sketch. Now that we have this in place, we want to extrude this. So we want this plate to be extruded by 3/4 of an inch. We want it to be a nice beefy extrusion. So we're going to go to 3D model, click on extrude. And remember, if Inventor can't figure out which geometry you want to extrude, it won't highlight anything. but it will highlight this profile saying, hey, you need to tell me what I need to extrude. And so if you hover your mouse over top, you can see different things highlight depending on where you've hovered. So I don't want to extrude, you know, these things. That's not what I'm after. But if I accidentally do that, I can either click cancel and undo the whole thing, or I can hold control in and click those areas again. Don't click out here on the actual extrusion, click on the base of where that extrusion comes from. That's how you remove a selection for extrusion. I want to extrude this area. So I click on the area that's highlighted when my mouse is in the bigger area. And then in the other section, what I do is I say that I want this to be 3/4 of an inch because that's my requirement. That's what my requirements say to do. So there we have it. So now we have something that looks just like what what it's supposed to look like. So moving forward now, there's another bit that we need to add. We need to make something so that we can add an axle and we can mount to this hub. To do that, we want to create another sketch. So we're going to create another sketch onto this main surface of this hub. To do that, I can right click on that surface and say new sketch. And then what'll happen is I get shown that plane with its origin right in the center of my screen, and I can start to draw on this. To do this, I want to make a hole. Now let's take a look at our requirements. Draw a circle on one of the faces of the hub. That's what we're lining up to do. Create a circle with a diameter of 1 inch. So this 1 inch circle is going to be centered on the center of this disc. And then we're going to make the hole. Okay, so let's start out with those things. So I'm going to grab a circle. We're going to anchor it to the very center here. And we're going to make that 1 inch. Okay, so now we have a 1 inch hole. Pretty easy. So now, if we want to put a hole in there, we can click extrude, and we don't want it to actually protrude like it's like a button off of the surface. We actually want it to be a hole. If we look on the back side of this, there is no hole. This looks more like a button here, and that's not what we want. So to control this, we can actually push in the other direction. So rather than protruding out in this direction, we can get it to push into the other direction by clicking this button. And what Inventor does here is it understands that if you're pushing into something that is already solid, it knows that you likely want to remove the material that's there. So once again, let's undo this. You see here, because I'm going out into thin air, it says you probably want that to be solid. And so it has automatically selected what it calls a join. When I push into material, it goes into the material and it switches this to cut. So it automatically has switched this. Now, if I go and I switch that to join, I can do that, but it's not doing anything. As a matter of fact, if I try and say okay to this right now, it'll actually give me an error. And what it's going to tell me is that you haven't made any changes with this extrusion. That's basically what it's telling you. You can tell that by expanding out the error, and it kind of gets in and it says there's problems building this extrusion. It's all very talkative here, but in the end it boils down to this, and it says this feature as specified did not change the number of faces and blah blah blah. Basically it's telling you didn't change anything. You extruded something, you extruded a solid into a solid, and there was no change. If I would have done this, flick this in, set this to join, but I made it go a little bit further and said, make this an inch, it would protrude by 1/4 of an inch out the other side. It's kind of a weird way to do it, but I could do it that way. And that it's okay with, because I've changed the overall look of the model. Okay, I've increased the number of, or I've changed the number of surfaces that the model now has. It's a very odd way of doing that, but there you go. So instead, what I'm going to do is I'm going to make this a cut. I'm going to make this a cut of 3/4 of an inch, and it's going to go through here so that I end up with a hole down through the middle of this disc. And that's it. So now I have this hole in the middle of my disc. So that is where the axle is going to end up running through this hub. Now, I don't know how many of you have familiarity with how to mount hubs to axles and things like that. Maybe you've done it on go-karts, or maybe you've actually assembled a drivetrain on a robot in the past, or some other experience. But typically what happens is there has to be some kind of mechanical lock that connects an axle to a hub. And just like how you have a mechanical lock using bolts to bolt a rim to the hub, you also need to have some kind of mechanical lock that locks the hub to the axle. Typically, how this is done is by using something called a key. And the key is a piece of material that binds the two pieces together. And it's specifically designed so that if there is a failure in the system, such that a wheel gets stuck and the axle turns harder, or you have so much torque that things kind of need to deform in order to allow physics to do its thing, it's designed so that the key that joins the two things together fails before the hub or the axle, because chances are the key that we're going to be making is going to be cheaper to replace than the hub or the axle itself. So it's built to fail first, so you don't ruin everything else in the system. Okay, so that's how this design happens. So that's the reason for a key, but now we need to incorporate it into our model. So to do that, we could create another sketch to incorporate a keyway. But instead, what I'm going to do is I'm actually going to add it to our existing sketch. So to do that, you can look over on the side here of your model browser, and you see this extrusion is the one that we just created. You can expand this and see the sketch that's involved there. And I can right click this sketch and say, edit this sketch. So now I'm back into where I was before with this 1-inch circle locked into the middle. And we want to add a rectangle into this sketch. So that's great. So now I've done this, and that's obviously not where the keyway is going to go, but it's a start. So to continue doing this, what we're going to do is we want basically to make the keyway an opening inside of this circle to allow us to insert a keyway. Okay, so here's what we're going to do. So I'm going to zoom in a little bit here, and the keyway that it's telling us, the key that we're going to be creating later on, is 1/4 inch by 1/4 inch. So those are the dimensions of the key. So that means that the key needs to insert into here. So that's easy. The first part is we take this rectangle and we're going to make this 1/4 inch. And then similarly, we're going to take this dimension and make this 1/4 inch. Okay, so now we got a square here, and that's great. It still floats. You know, we haven't constrained it anywhere, but we've actually constrained its dimensions. So now our design is telling us we need to center the rectangle horizontally to the origin. So essentially what it's telling us is it needs to basically be centered on this circle so that half of it's on this side of origin and half of it's on this side of origin. What's the best way to do that? Well, we could do it in a number of different ways, but an easy way to do it is to grab this edge here and then grab the origin there, and now you have a measurement between the two. Now I could look at this and go, okay, I know that half of a quarter. I can do that math in my head, but why bother? I'm going to take this and set this dimension here and say this edge here, this 0.25, I want half of it to be this dimension. And so now it has gone and calculated that that is actually 0.125. So later on, if I say, well, no, we've got some weird things here and it's actually a metric key. I don't know if there's such a thing. I think there is such a thing as a metric key, but say we change this and it's actually going to be, it's actually an 11 millimeter key that we're going to use. I can change that to 11 millimeter and this will automatically figure out the halfway point. Had I hard coded this to be that 1/8 of an inch, then I would have had to change this also. Okay, but that's not our case here. So this is actually going to be 1/4 of an inch. So we've got one of those dimensions. So now if I start doing this, I can move this, but I can't move it in this direction anymore. It's locked into that position. Now this position, I can still play with it. So we're going to need some additional constraints. So now it's telling me that the rectangle, so constrain the rectangle so that the top of the circle intersects the center of the square. There's a couple of different ways that we can do this. I'm going to show you, one way that you could do it. Like I said, there's lots of different ways that you can do different things in CAD, and some are better than others, but you'll figure that stuff out as you get to be more experienced. I can do it the same way we did in part 1, where we wanted to center on a circle. So I'm going to show you this method, and then we're going to figure out whether this is actually a good way of doing this or not such a good way of doing this. So I'm going to select the line tool and I'm going to select construction. I'm going to take this here and put the construction lines diagonally and then do the same thing here like that. And so now what I've got is I've got a center point where these two construction lines meet. And what I can do now is, because I know that this circle is is 1 inch in diameter, which means it's half an inch in as the radius, I can actually take the center of this and I can take the center of this and the center of that and use those as reference points for each other. So I can grab this here. I thought I could do this here. So I can grab a point here and place the point right in the center. So grabbing this point here, and then what I can do is anchor now, grab this point and bring it down to here. And then I can specify that this needs to be half an inch from the center. Okay, so now I've positioned this thing so that this 1/4 inch, the center of this 1/4 inch square sits right at the edge of the circle. So now you'll notice it's all purple and it's all locked in, so I can't move this thing around. Okay, notice this also is one of these types of measurements that wasn't like an angled dimension, but a horizontal dimension. It could have been an angled one also, because it's locked in left and right. It doesn't matter which kind it is. So now I have this circle here. The end result is I want to have it kind of notched out like this so that the key can sit in there. Okay. So to do that, I need to try to trim out some of these other edges so that I end up with a cutout for the keyway. To do this, I can use a tool called trim. Okay, and here's the trim tool. So if I use this and I hover over some lines, what it'll do is it'll highlight it in kind of a dotted line, and and the highlighted dotted line is the piece that I'm going to trim. What it uses here is it goes along the line until it finds a change in the line. Either it meets up to another line or it runs out of line. So you can see here, when I hover over this, the endpoints here and here are the limits of this line. So that's what it's going to trim. So if I get rid of that, now it's gone. And if I do it again, you can see from this point here up to the circle is where it's going to trim. And if I do this to here, now it's gone. And if I do this to here, now that's gone. Now, here's a problem. Okay, so I tried to trim a line, but Inventor is getting angry with me. And the reason why it's getting angry with me is because I'm trying to trim out a piece of geometry that it's using in order to constrain some things. Okay, so I'm basically saying I have existing constraints that exist in this drawing, but now I'm trying to remove those things that it's dependent upon. So I either need to get rid of those dimensions first, like that, and then trim it, and it'll still run into problems. So I can now get rid of some of these other things that it's dependent upon, like this, and then try and trim it. And there it is. But in doing all of this, I've basically lost all my constraints. So now I've got this going on. I've got this going on where I can move these things however I want. There's all kinds of things that aren't great here. And so this probably wasn't a great way to go about figuring out exactly, how to constrain this square. So instead, I'm going to hit Control Z a bunch of times and back us out to the point where I said we had a choice. Okay, so here we are again, back in time at this 1/4 inch by 1/4 inch square constrained, and it's only constrained left to right on origin. What I want to be able to do here is I can use some math that's going to save me a bunch of time. So I can actually go and say this edge here. So even though my drawing or my description said the center of the square needs to be where the circle perimeter passes through. So the edge of the circle needs to pass through the center of the circle, center of the square. So I can use math here instead. I know that this here is the diameter of the circle. So I'm going to say, okay, so half of that is to the edge of the circle. Okay. And then I also know that the half of the square can be this divided by 2. Okay, so now I've given it the center of the square and I've given it the edge of the circle, and I subtracted the 2, and now I have everything locked into place. Okay, and I've made it based on things that are going to still be here in the drawing. I haven't made it based on these other things. So for example, now if I try and trim this, if I trim that and trim that and trim that and trim that, it's okay, right? It's okay. These things aren't it's not fully constrained, but it hasn't complained about its position. So if I try and figure out what's actually moving here, if I try and move these things, I'm having a difficult time actually moving any of these things. And the thing that it's kind of angry about here is if you can't figure out exactly what it's angry about, so you have things, you can't move it. Okay, if I try and move these things, it's not actually moving. So it seems like it's constrained, but yet it's not purple like the rest of it. So if you can't figure that out, you can use another way of doing it. And actually in the bottom corner here, you can see it thinks that 2 dimensions are needed in order to fully constrain it. And if you don't know what those dimensions are, what you can actually do is you can use this button up here. And what this does is, and I never like using this because it usually creates some pretty bizarre dimensioning or some constraints. But I put it in here to try and sometimes see what it wants. So I'll hit that button and it says, okay, you need to add some constraints. And I'll say, okay, go ahead and apply those constraints. And then I'll look at it and go, oh, it wanted me to apply horizontal and vertical constraints. Obviously they're horizontal and vertical, but I didn't put the constraints in, so I didn't realize that's what it wants. So if I hit escape, if I say remove here and hit that, and I'll go and hit Control Z here. If I just take this and say this vertical constraint, I want this to be a vertical constraint, and that automatically becomes a vertical constraint, and this becomes a horizontal constraint, and now we're all set. Okay, so now we've made a keyway for our hub. Okay. So the next part that we want to do here is we can finish the sketch, and you can see that it protrudes out here, and that's kind of not what we want. So instead, what we're going to do is, actually, in looking at this, I realized I did this backwards. And I noticed it earlier, but I trusted the slides, and the slides are wrong. So I am going to correct this. I actually want this to protrude the other direction. So you make a mistake like this, and you figure it out. Okay, so what I actually need to do here is I can fix this by simply saying the top of this line needs to be elsewhere. So if I get rid of that, you can see that I can do this and protrude it out the other direction. Okay, so instead, what I'm going to do here is I can fix this by saying, okay, the edge of that circle I know is 1.5 inches. But what I want to do is I want half of the square to protrude above the perimeter of that circle. So I can take the height of that square and make it the center of that, and there that is. Okay, so now I've got this thing actually positioned and cut correctly. Okay, so you can see how it makes sense to use some of this math stuff and rather than just free sketching and just modify constraints, and it becomes fairly straightforward to make modifications that look fairly large, but they're easily modified. So the next step is we need to actually make a hub to go around this. Okay, so the axle is actually going to go in here, but what we want to do is we want to get to the point where we have a hub that looks like this. Okay, our goal is to make a hub that protrudes out that allows an axle to go into it. Okay, so to do that, we're going to create another sketch. So we create another sketch here. And this hole needs to be a 2-inch circle from the center. So I'm going to do this, and then I'm going to make 2 inches. And since I anchored it starting at origin, it's a fully constrained circle now of 2-inch diameter constrained on the middle. So that's great. I have that. And now what I want to do is I want to extrude that circle, but there's a problem, because what I've told it is that's a circle that I want to protrude, but in doing this, I've kind of covered that hole, and that's not what I want. Okay, but what I don't want to have to do, so I'm going to hit cancel here. What would be a lot of work is if I would have to draw that circle again and do all that keyway math and all that stuff. And then if there was ever a change in the size of the keyway, then I'd have to visit 2 sketches, and that's just too much work. So instead, what I can use is this tool called Project Geometry. Okay, so I can select this tool, and what it does is it allows me to select edges of the model in other places. So if I go here and I select this, you'll see that it turns yellow and it says, okay, that's an edge now that I've copied, but it was from another sketch. It's an edge of the extrusion. So then I can continue to do this and select all of those. And now essentially what I've done here is I've taken the profile of that cut and I've brought it in to this sketch. Okay, so now if I hit OK here and I go to extrude this now, you'll see that it is now part of that drawing and I can extrude this how I want. Okay, as a matter of fact, now if I go back to this sketch and like I said before, made this to say that this is actually going to be an 11mm keyway instead, and I say finish here, that was translated back into this projection. So as I change something earlier in the model, that because I projected that geometry, it comes through into this sketch and it alters automatically. Okay, so even though there was dependency upon that thing, if that thing changes, so too are the updates to the dependencies. Okay, so that's another very good reason, because otherwise I'd have to make, if I wanted to make that change and both sketches had that math in there and dependent upon the dimensions that I assigned in that sketch, I'd have to edit 2 sketches to be able to make the key change. And I don't want to have to do that. So now they say, no, you know what? It wasn't an 11mm. We were actually right the first time. It's actually a quarter inch key. We were right the first time. And so now it all gets fixed up. So we're kind of ahead of this slide here, but this is telling us now it needs to be extruded out to 1 inch. So I'm going to go back into this extrusion. Oh, and it is already constrained to 1 inch. So that's actually correct. The next part of this is we want to use the fillet tool. We have some rough or some hard edges here. So we're going to use the fillet tool, and this fillet allows us to specify a radius on this edge. So if you see here, I've kind of rounded the edge off of that. Okay, so if I say okay here, you see the one edge is now rounded and there's a radius on it, as opposed to this side that's a hard edge. Okay, so what I can do is I can soften up all of these edges so that you don't end up cutting your hands on these things with a sharp edge like this. I can add to this fillet also other edges to this fillet as well. If I double click, and then I can add another edge and another edge to those fillets there. Okay. It's also indicated that it wants me to do a 1/4 inch radius. That seems like a pretty big radius to me, but that's what it's asked for. So there's our radius. I think that's probably a typo though. So I'm actually going to put that back to 0.125. That seems like a better radius to me. All right, so there's our hub, and it looks just like the drawing, except for color. And this is telling us to say, select gold from the top pull-down menu. So if I look at this here, this is where our color palettes are, and we can color our parts the way that we want. So in this case, I'm going to make it gold. And there is our hub. Okay, so this is the first piece of a 3-part assembly that we're going to be creating. This is by far the more complicated one. In our next session, we're going to create the axle and the keyway and then put it all together. Okay, so this is all we're going to cover for this session. Before we close everything down, what I'd like you to do is to save this part as hub. So save this in a place where you're going to remember where it is, and I'm going to save it on my desktop, and so that we can use it next week when we start using this assembly. So save this away in a place that you'll remember, so that in a week's time you know where to go find it for a continuation for part 3 in Introduction to Inventor. So at this point, I'm going to open it up. If there are any questions, then feel free to, I don't know, raise your hand, or however we end up doing this. Daniel, if you could give me a hand here for how to do that.
Sure, people can type it into the chat, or just use directions and raise your hand for any questions that you might have.
All right, so it doesn't seem like there's additional